Hello everyone. Welcome to Singapore Geospatial Week Plus 2020, an event organized by GeoWorks, Singapore Land Authority's Geospatial Industry Centre. So we are pleased to bring to you 2 weeks full of geospatial webinars spanning various industry tracks and international speakers. So today we are excited to introduce Mr. Jimmy Tan from JTRS to share more about capturing reality at Singapore's Changi Airport. If you have any questions during the webinar, please leave them in the Q&A box and then we will answer them at the end of the webinar. So thank you, and without further ado, I will pass the presentation over to Jimmy. Jimmy, please. Thank you.
All right, good afternoon, ladies and gentlemen. I guess you all can hear me and see me. I'm excited this afternoon to share our experience and expertise on the 3D laser scanning methodology for BIM. I will feature our recent completed capturing reality projects, and hope after this session, you will take away a better understanding of what the real world of capturing reality. Before I begin the session, let me introduce myself. My name is Jimmy Tan. I'm the practicing registered surveyor in Singapore. I'm the owner of JTRS Registered Surveyor, and we are established since 2009. And we are based in Singapore. Well, you can find us in the foreign website, www.jtrs.com.sg, and in fact, you can do a screenshot, the QR code screen that you can go to my LinkedIn. So a very fast introduction of what we do. We are actually a professional land services company, providing a wide range of services such as 3D laser scanning, photogrammetry, and imaging. And we also constantly source and think of creative ways of carry out the survey, so to maximize the survey output for the projects. In summary, we capture and manage point clouds. Those images you see in these slides presentations are actually taken by myself. Let us begin with what is reality capture. Reality capture is an activity that quickly and cost-effectively collecting the best and most accurate data about real-world conditions in 3D. So what you see, what we capture, and what is being transformed into a 3D model is what the real world is. Okay, for example, in these slides, you see it's an actual site in Singapore. Facing north is Malaysia, Johor. And even at low tide, we try our best to balance ourselves in the mud to capture the structure, the building outlines, so that this is what you will see the point cloud data. It's all draw reference, it's all been skilled, looking at the real world. And this information can be used to develop into a 3D model later on, either in mesh model or BIM model. Let me show you another example. This is also in Singapore. Esplanade Park Memorials. It consists of 4 monuments. Let me go straight to one of the monuments, the Tan Kim Seng Fountain. What you see here is actually a digital image, no different from any other images that are taken from the digital cameras. However, after the scanning, what you see on the left side of the screen is actually the point clouds. And what you see on the right-hand side is actually the images plus the point clouds being merged together. We call it colorized point clouds. From this reality capture, we are able to transform into either a 2D drawing, as what you see from here. It looks a real kind of structure. You can see actually the baby face looks like a real person. And we also be able to transform into a 3D model. In this screen you see here is actually a photogrammetry plus 3D scanning methodology. In fact, we did a scan for this monument or this fountain. We used 1 mm spacing to capture the detail, small detail of the fountains. Let me carry on. You may ask, what is a 3D laser scanner? For some who are not familiar in this field, may not know what is a 3D laser scanning or 3D laser scanner. In short, 3D laser scanner or scanning is a non-contact, non-destructive technology instrument. What you see here, a green line, is actually a 3D laser scan. All right, and it captures the profile of this. For example, it captures the profile of this facade and become a 3D points. So this is what the 3D laser scanning would do. In the market, there are a lot of scanners. Come in small size, come in big size, come in different grades, surveying grades. Scanners is the same as the total station. It has different grades. You have a high-end accuracy and low-end accuracy. It has different purpose. So for here, you see, for one is on the left is a P40 scanner. It's bigger and more accurate. I will go more on detail in the following slides, how we use these scanners in a few. Let me show you another slide where this is where the mobile scanner comes in play. One is on the left is a backpack, and the one on the right is a new BLK to go with the handheld. So with all these different types of scanners, how do we use it or when do we use it? It all depends on what is the project requirement and what is the deliverable. Okay, all about, I have said so much about capture reality, 3D laser scanning. Let's go to the project itself. Recently, we just completed the scanning to BIM for Changi Airport Terminal 2. Okay, look at the map, courtesy of Google Map. Look at the plane, aeroplane parking on the aircraft stand and also in the taxiway. You can see the view, the scale of this whole entire building. A total of 600,000 square meter of floor area that we need to scan from basement all the way to level 6 and even to rooftop. We also scan the mechanical, electrical, and plumbing, MVP in short, at the above in false ceiling, above the false ceiling. If you screenshot the QR code, it will link you to an article that we written on this project in particular. There are more information on this project itself. Other than the scanning, we also talk about control points and so forth. So Singapore, Changi Airport is famed for its calm atmosphere and a smooth running of operations at the airport. And it's a long-standing reputation as the world-leading airport can be largely attributed to the management progressive and innovative approach to running an airport. And to further enhance aspect of such FM of facilities management on an ongoing basis, an accurate and precise 3D model capturing every aspect of terminal of architecture, structure, and MVP is required. Let's go to more details. I was showing a lot of slides captured that we do on site. So here's a few of what is. Although this presentation is titled as Singapore, Capture Reality in Singapore Changi Airport, but the workflow, the equipment used, and the software that we use can be also applied for other projects, small or big. Because a lot of old buildings, we don't have existing drawings, even we have existing drawings, it may not be accurate. So the best way is to capture them in terms of 3D scanning, and then we have a 2D drawing or 2D model. There are a lot of advantages of having a high accurate BIM model. And this information can be used for future A&A works, such as to check any crashes during the design stage. And also the data is always up to date and all in digital platform. Scanning the entire building accurately and building the BIM model can actually help the FM in managing the building. For example, the type of lighting installed in the ceiling, when was it made, or where was it made, and when was it last replaced or changed. When doing the BIM model, the question will ask, what is the level of detail? When a designer designs a new building, the level of detail can be go to as high as LOD 500 or the highest level in the constructions. But in the existing building, it may not be a practical to have a high level details, because one thing is higher the level of details, the more costly it is. And if let's say the attribute data is not available because the equipment or the material has been installed for 20 years, 30 years ago, and such information that not available may become a useless BIM model. Because in a BIM, we need to have all these attribute data so that to help to manage the whole entire buildings. Okay, let us go through the equipment list. Not so much of the list of all the scanners, but the equipment that we use. This is a workflow that we do. On the left, we have the Leica P40. On the right, we have a BLK 360. These two are the scanners, one big and one small. And then the one in the middle is actually a 360 degrees panoramic cameras to work together with the P40. Although the P40 has internal cameras, but in terms of the workflow, is a bit slower and less resolution than the iStars. This is how the iStar will look like. And the one on the right hand side is the iStar mounted on the tripod. Okay, this will be the same position as the scanner. After scanning, we take out the scanner and we place with the iStar, and we do the capturing of the scene in 360 degrees. Okay, this is the image or the site actually taken with iStar cameras. It's a 300-degree panoramic image. And what you see right in the center is actually a scanner. So we have actually two tripods. One is the scanners, and one at the back is the cameras. Let me share some of the images, some of the screenshots actually that is taken on site. This is actually the actual site, the Terminal 2 arrival hall, I think. Yep. So you see the colors. It looks like a digital image from the digital camera. But in fact, this image is actually point clouds with images. Meaning to say, you click any part of it, the ceiling and the floor, you have a distance. You want to measure the length of the table, for example, you get the dimension. Another example, this is also part of the building in the roof. And you can see it's well lighted up and well colored. As we know, Changi Airport is a very busy operational airport. You can see here, for example, at Terminal 2 departure hall. All right, you see a lot of people checking out, checking in to board a plane. And the airport cannot stop operation just for us to do the scanning. And in fact, when we're doing the scanning at the baggage system, the conveyor belts are still running. And you can see the luggages actually moving very fast in the conveyor belts passing us. So we need to map out the whole entire terminals, interior, exterior, even inside the toilets and above ceilings. Well, the airport is still operational. So the only way to do this is scan or survey during the off-peak periods, off-peak hours. Hours like the last bus leaving the terminal, like last airplane or plane flying out, or last plane landing. So after that, there will be a period where there's less passengers and we can start our scanning. So we have a lot of planning and a lot of replanning and rescheduling of work we carry out. In fact, in the plant room like this, we in fact need to apply permit to work, even on the rooftop. You realize that all my slides, you see tripods, wooden tripods, all right? We don't use aluminum tripods for one reason, because wooden tripods is more stable and able to absorb heat and vibration very well, especially when we have a heavy scanners on top. Okay, what about above ceiling? This is one side that, yeah, you have above ceiling, but yet you have catwalk to walk. So you have space to walk around. How do we do it when there is no space? Let me pause for a while for you to look at these images. You realize that we use a big tripods, more than traditional tripods. We also use a heavy duty ladder for us to climb up and mount the scanners on top. Well, those were the days, because this probably you need to have a big lorries or van to carry the tripods and the ladders. But those were the days, because we have this. We have BLK 360, which is small, light, and fast. And we just mount on the light or spacer stand. And then we move around with a dolly. You can realize that there's a dolly at the bottom. So we can actually push around easily. You don't have to carry out. And at the same time, we also mounted some lights so that you can shine into the space above the ceiling, which is actually most of the time are totally darkness. Of course, with the current new Leica RTC, you actually can use that to do the job. So you may ask, such a big area, we have set up 23,000, more than 23,000 setups. Meaning you say, you set up tripods, you put the scanner on top, you start scanning. This is one setup. So we did it for 23,328 times of setups. But how do we stick together or join all these scans together? Well, some practice use targets based on the wall. Some use spear. But we only have a tripods with scanners. We only have 2-man scanning team, 1 team. We don't place targets. We don't use spear. We don't even use another survey team to pick up the targets using the total stations. All we have is this, Leica Cyclone Register. With so many setups, we use a feature in the Cyclone Register called visual alignment methods. With this method, we cut off manpower, we cut off pacing of targets in case you forget to bring down the targets after the survey. The police officer in the airport will go after you. So we use this method to align the whole entire scans. In the end, we have about 8.6 terabytes of processed data, 2 terabytes of raw data, and of course, another 2 terabytes of ISTA images. It's a huge database and a huge space that we need to clean up. So another image showing the fan, aircon fan. It looks like a digital image. It's very sharp. You can even see the cable piping on top. But this is actually a colorized point clouds. Another pictures. The color, the orange color is the true colors. And this was, we take great care of where to position our scanner so that we get the maximum angle capture of the objects. Another example, colorized point clouds. You realize that the floor, or the catwalk floor is very close to the scanner. In fact, we place the scanner on the floor without any tripods. This is the space between the catwalk and the ceiling is so narrow that we actually had to leopard crawl across. Okay, so much of the examples. Now let's look at another examples of point clouds and a BIM model. What you see here is actually colorized point clouds in UCAP. And what you see now is the BIM model developed based on the point clouds. Let me go back again. Do you see any, can you spot any difference? Yeah, probably there's a human being there, but now without human being. And this is also another aircon equipment on top of the roof. This is not a single image, although it's a screenshot, but it's not a single data. It's actually a merge of all the scan together become a model, and this screenshot is just a single screenshot from there. And this is the model. It all depends on the project requirement. What I mean is the level of detail. For this case, you realize that the level of details is a bit not that high because it's more important to have physical objects showing is there rather than the more detail unless required. And of course, the color. Okay, the color of the model is also very, very critical because each color actually represents a unique ID for the owner or for the system. So the system owners will know, okay, this, looking through the model, we know, okay, this color represents for what purpose. This purpose is actually air conducting, for example, and so forth. So we have to work very, very closely with system owners and to understand each other, what is the requirement and how we can produce the best solution for them, the best model for them. Okay, almost coming to the end. Okay, take a few seconds to look at this screenshot of the Terminal 2 departure hall. Why I say that to ask you to take a look is because this is going to be a history in a years or two, because Terminal 2 is going for a major facelift and this is going to change starting this year. Well, our effort to scan the entire buildings and also to model them accurately has paid off. In a way, the data and the model has been used for designing and constructing the new interior. Because what I've shared with you so far, all the slides, based on our experience in executing the projects. There might be flaws, but this is a workflow that works for us. I hope this sharing and this workflow sharing techniques, you will get some hint or get some idea how we carry out this project. Likewise, you can use this for your own other projects. Well, my ending part is that as a research surveyor, I'm proud to come this far. Being able to contribute our services by adopting new ways of surveying or scanning and be part of the development process for building the future. Well, I come to the end of my presentation. Likewise, this is my website and my LinkedIn and my email. You can always contact me. I thank you so much for being with me. So now it's question answered.
Yeah. Yep. So now we have some questions at the Q&A segment. So perhaps you can also look at the Q&A chat.
Wow, I have 10 questions. Okay, the first question asks about, can we convert the 3D model into a GB XML format? Well, we don't do that for now. Probably it can, I'm not so sure because we don't do that for this project. How long does it take to complete and how much does it cost? You're talking about this project? It costs a lot because it's expertise in the workflow that we do. And how long it takes, it all depends on the approval period because there are times that we cannot access, there are times that we can access, so there's a waiting time. So in all, it took about 1 year plus as we go along. How long did it take to convert, How long did it take to convert the scans to BIM model and how big are the BIM model files? Well, we progressively, after scan, we process it, register it, we clean up, and then pass on to the scanning modeling team, or the BIM modeling team, and from there it models. So it's not that we finish everything, then the BIM model will start modeling. So all along, it all completed within that period of contracts. Next question is, can you pick structure member information covered by the architecture panel? Sorry, okay. Can you pick up structure member information covered by architecture panel inside ceiling and member that will be blocked by services or ducting? Okay. We're doing the scanning. What is the same as taking your pictures? What you see is what the scanner can see, line of sight. For those areas that is a block, for example, because we cannot open all the ceilings, we can only see ceiling from one side, and the other side probably blocked by, let's say, air conducting. So we miss some information on the other end. For this case, a lot of time we have to depend on the existing 2D drawings. 2D drawings as in the structure drawing or in the MEP drawings, or even sometimes schematic drawing will also be helpful. So we have to have all this information on hand. Let me go back to the other question. How was the survey control managed in such a large project in ensure high precision of survey data and created as built BIM model? Well, it's, you give me a project, I'll tell you how to do it. Well, anyway, we do away with targets based on the wall. We do away with target sphere. So what we do is in the Cyclone, like a Cyclone software, register software, we actually use it for visual alignment because it's all walls, concrete walls. That's the best way to do the alignment. And of course, end of project, we also have a QC on our data, scan data, and at the same time on the BIM model. So there are a lot of other QCs that we have to develop in order to end this project so that we know that this project is being executed correctly. Okay, next question is how to provide modeling services based on point clouds. We use a lot of software, in fact, that to come to, basically we are actually tracing the point clouds, whichever software that comes along. I think what the software that we have is important that we have is a CloudWorks, like a CloudWorks, that actually allows you to bring in the data, point clouds data into your, let's say, Revit or into the AutoCAD. Because this is important, because in Revit and AutoCAD, they can't handle the point clouds very well because point cloud itself is heavy, huge in the database. Is it possible to rent equipment? Not for me, but probably the supplier. How do you transfer Sorry, the screen keeps going up and down. How do you transfer terabyte of point clouds to BIM software? Again, we don't transfer them, but we use them as a background for the BIM modeling. So we use another software called, as I said earlier, the Leica CloudWorks as to support the database. Do you have time for next few questions?
Yeah, Jimmy, so due to the time constraint, perhaps you just choose one,
okay,
one last question. Yeah.
Okay. There's a lot of questions here. Okay, is conversion for point clouds to BIM automatic? No, because there are software that actually can bring the point clouds to the BIM model automatically. But the danger is too automatic, they mess up the whole entire information. So there is labor intensive. That's why scanning to BIM is not cheap. Okay, as a surveyor, accuracy important? Yes. How is accuracy using laser scanner or scanning equipment? Basically, the P40 is a very good, graded scanner. We are talking about 2 to 6 mm in terms of the mesh, in terms of the 3D points. Okay, not a single point, but a 3D mesh points. So we're looking at 2 to 6 mm. But of course, another part is the georeference it. Of course, that it will be another story of it. Georeference the whole entire model, whole entire point clouds. That one is we have to work with the control points. Okay, one question is, I think we have one last question. How will it apply to underground works in future? Well, as I said earlier, 3D scanning, 3D laser scanning doesn't penetrate underground. It's a line outside. What you can see is what you can scan. So I don't know how you apply undergrounds, as long as I can go underground in a tunnel, I can do the scanning.
Okay, thank you so much, Jimmy, for today.
I think there are a lot of questions coming. Sorry, I can't answer everything.
Yeah, thank you everyone for the engaging questions. So before you leave, please check out our other webinars by scanning the QR code. Also join in the conversation using the hashtag SGGeoWeek. So thank you, and we look forward to see you again.
Thank you.